Hear that? Believe it or not, summer is just around the corner. Luckily, Armor All, America's most trusted auto appearance brand, has what your car needs to get that perfect summer shine. Plus, now through May 31st, we'll give you $5 for every $20 you spend on Armor All products. That means car wash pods, protectant, tire shine, you name it. Find out how to get your $5 rebate at armorall.com. Armor All, less work, more clean. Terms apply.
BoShield wasn't satisfied with any of the bike lubes on the market, so they engineered their own. Their research proved that none of the Teflon, silicone, or synthetic formulas held up when exposed to dusty, dirty, and muddy conditions. For that reason, BoShield T9 is designed to offer long-term lubrication and protection in any environment. BoShield T9 waterproofs your bike chain, lubricates cables, and prevents rust with its effective all-in-one formula. The paraffin-based lube flushes out dirt and old lubricants, displaces moisture, and penetrates moving parts. Then it dries to a clean, continuous wax film that performs better than Teflon and lasts up to 200 miles. BoShield T9 is designed to resist picking up dust, dirt, or mud, which makes it a good choice for all riding conditions. This month, BoShield is giving away a free prize pack to a lucky listener. Go to singletracks.com/BoShield to enter and visit BoShield.com to learn more, or click the links in the show notes. Hey everybody, welcome to the Single Tracks podcast. My name is Jeff, and today my guest is Vittorio Platania. Vittorio is the marketing manager for the Formula Group based in Italy, and he's here to fill us in on everything we need to know about mountain bike brakes. Thanks for joining us, Vittorio.
Thank you guys very much. I'm very happy to be here with you today.
So let's start with an overview. How do hydraulic brakes work? Starting, I guess, at the lever.
Yeah, the way how the hydraulic brake works is in theory very simple. You have a piston, which is first of all is a closed system, because as you may know, oil is not compressible. So it's a closed piston with oil inside. This is the reason why it's very important not to have air inside, because air is compressible. And you have a piston from one side, which you control with your master cylinder, with your lever. And when you push that piston from that side, you're pushing the oil, which is not compressible, that is pushing the pistons. And the pistons are pushing your pads. This is how it works. Of course, the system needs to be closed, with no air inside, and well balanced, because it's everything about leverage ratio. So the way how you design the master cylinder and the way how you design the caliper will tell you how the feeling of the brake is going to be at first place. Then you can add some little things to change that feeling a little bit. But the main feeling is made by the way you design the brake.
Yeah. Well, and in a hydraulic system, you're basically multiplying force, right? Like the force you put in at the lever in the master cylinder is then multiplied once it reaches the caliper. Am I saying that right?
Exactly. This is exactly how it works. It's like having a very good leverage ratio from your side. So with a relative small amount of pressure on the lever, you can have a very strong power on the rotor, on the pads.
Yeah. And that's one of the main advantages of hydraulic brakes over mechanical brakes, right? I mean, these days everything is hydraulic when you talk about mountain bike brakes for the most part. But early on, these were mechanical systems, right? Where you had a cable and, you pull the cable. As much as you pull the cable, that's how much it's going to squeeze the caliper, right?
Exactly. This is the real advantage. And this is the reason why by then I remember, if you remember, we had also, how do you call the like pads, like non-disc brake, but hydraulic actuated.
Oh, right. Like rim brakes.
Yeah, exactly. Rim brakes, but hydraulic actuated. They were way better than the mechanic actuated one because of the leverage ratio. I wouldn't say better, but they were more powerful.
Right.
Sure, depends on the application, but they were more powerful. So yeah, the first call. This is at first place. This is the reason why hydraulic disc brakes are an advantage, I would say.
Yeah. Well, you sort of hinted at it, but what are some of the variables that go into making a set of brakes more powerful or giving brakes more stopping power?
Wow, that's a huge topic because every single thing you change in a system will affect the power, the feeling, pretty much everything on the brake. I'm talking about the size of the master cylinder, so the amount of oil that you can use, the way how for example, the numbers of pistons, the diameters of the pistons. So every single thing you change will affect the feeling and, of course, the power. In order to make it more powerful, I make an example, for instance. So you could have like the same system as we have on the Cura 2 piston and the Cura 4 piston, with one caliper with 2 piston and another caliper with 4 piston. The 4 piston is more powerful, but sometimes while you're riding, the perception of power and the real power are two different things. For instance, if you have a brake which has a very strong bite, maybe you have the feeling that you're having more power on your brake, but maybe it's not. Our Cura 4, for example, has a little bit less bite than the Cura 2 piston because it's the same amount of oil pushing 4 piston instead of 2, but it's more powerful. So to answer your question, when it comes to power, it's not so easy to define what actual power is on a disc brake, because you also, but this is I don't want to open another topic. You also have to consider the range of use. For example, I'm sure you know that some magazines, some review out there, especially here in Europe, they use like the labor test to see how the brake, how powerful is the brake.
Yeah.
And by doing this, most of the time they push the brake to the limits. That means like rotor on fires and stuff like that, something that you never reach in a riding situation. Right. And if your brake performs well at that stage, that means that is the most powerful. But unfortunately, this is not true, because the way I would describe the brake, the hydraulic brake is a little bit more like a lung. So there are so many things that can affect the brake from the outside, the heating temperature. So, and the brake will change its performance based on these elements. That means that maybe a brake that is super powerful in that scenario, which is not a riding scenario where like the rotor is on fire and stuff like that, has not the same power in a riding scenario where you apply, I don't know, maybe 2 kilogram power, like leverage on the lever. So because every stage you are with the brake will react in a different way. It's like having a shock. When you set your shock, you are set with rebound and compression, or your forks. Then you go down the hill for 30 minutes, and the system get warmer. And the oil and the rebound, the setting will change a little bit. It's exactly the same with the brake. So it's very hard to say which is or how powerful a brake is if you do not set first a specific range of use.
Mm-hmm. Yeah. Well, yeah, it sounds like too that a lot of it is about feel as well. I mean, we may perceive a brake to not be strong or to not give a lot of stopping power, but really it comes down to feel, that initial bite, like you said. Yeah, there are just so many factors. And it's interesting too, we're seeing a lot of people, mountain bikers, deciding to go to 4-piston brakes just because I guess it has a better feel. I mean, but you would never add like 6 pistons to a brake, would you? I mean, does that make sense? Is there any need to do that? No.
No, absolutely not from our point of view, of course. So I tell you something, we had a lot of discussion before doing the 4-piston, because we had the feeling that our 2-piston, the Cura 2-piston, which actually is a very powerful 2-piston with a 26 millimeter diameter pistons, so as very big pistons, we had the feeling that were no need at all for a 4-pot caliber. That brake out of the box won the Junior Downhill World Cup with Finn Hiles, the world champ with Miranda Miller, the women world champ. And that was a Cura 2-piston straight out of the box. And okay, someone could tell, that's downhill, they don't use brake. Believe me, they use brakes a lot.
Right.
They do use brakes. Maybe they don't use chains sometimes, but they do use brakes. So there was a big discussion because, of course, there was a request from the market to have a 4-piston, because people, most of the riders, they want to see a 4-piston on their enduro or downhill bike.
Mm-hmm.
And we did the 4-piston for that way because, to be honest, at first place, if you have a very powerful 2-piston, a 4-piston, you're just adding something more to the system, mm-hmm. and something that can make it work worse in some sense.
Right.
Because you have 2 pistons more, you have to manage more the way how they came out, how they come back, the rollback. So, of course, if you add something to the system, let's say that the system is more fragile. So why you have to put other 2-piston if you have a great 2-piston?
Right.
But again, this was the request of the market, and we wanted to do a brake even more powerful than the Cura 2 pistons. And we did the Cura 4, which, if you ask me, is stupid power. It's like I mean, I'm sure you had sometimes that experience when you jump, you have a drop, you drop something with your bike, mm-hmm. and maybe you still have your hand, your finger on the rear brake lever when you land. And it's not a big deal because the impact is so big that, at least at the very beginning, the rear wheel, it's going to move anyway.
Right.
Not with the Cura 4. Not with the Cura 4. If you have your finger on your rear wheel while you're landing, your rear wheel, it's stopped. It doesn't move.
Yeah.
Do not move. So I'm not saying that this power is, let's say, not useful on a mountain bike, but it requires a very smart rider. To answer your question, the 4 pots is something that, if you ask me, should be used. I'm talking about a good 4-pot, not for many riders out there, because 90% of the riders, maybe they are good with a 2-piston. And 4-pot is more powerful, but you don't need more than that power. is not mountain bike anymore. Maybe a motorcycle, but not even a motorcycle. But
Really? Yeah, interesting. Well, you mentioned one of the other variables that can affect a brake's stopping power is the oil that you use, the hydraulic fluid. So why does Formula use mineral oil in the Cura 4 brakes? What's the advantage of mineral oil over other choices?
Yeah. I think that Formula was the last company to jump on the mineral oil thing. Beside, I would say, SRAM, which is still with DOT. But for the mineral oil guys, let's say, I think we are the last one, and we jumped on that technology with the Cura, and that was 4 years ago. So the reason why we took so long for us to have the mineral oil is because the mineral oil we were testing before the Cura was not good for our standards as the DOT. And we didn't want to compromise the performance of the brake. There was a big demand, especially in Europe and especially in Germany, for mineral oil. You could easily ask how things goes in Germany. Like dealers, they don't want to bleed or to manage or to service non-mineral oil brakes. So we wanted to, let's say, answer to this market request. But we wanted to do it in a good way. So we took almost 3 years to develop our own mineral oil, which is different from the others. If you look at the Cura mineral oil, it's completely transparent. It looks like water. Because the problem with mineral oil is that the advantage of mineral oil is that is not hygroscopic compares to DOT. So the DOT can, because it's hygroscopic, can absorb water, humidity. So let's say that the performance of the DOT will get worse and worse.
Yeah, it degrades over time.
Well, degrades over time. Where the mineral oil, because it's not hygroscopic, it will degrade a little bit at the beginning, but then it's stable in the time. So this is an advantage of the mineral oil. But the disadvantage of mineral oil, is that most of them are the boiling point and the freezing point the boiling point is lower than the DOT and the freezing point is higher than the DOT. And we wanted to have almost the same performance as the DOT. So in the end, we find our own recipe for the mineral oil, and we reached we have a product in the end, which is our mineral oil, which has a boiling point that is almost the same as the DOT, and a freezing point that is lower than the DOT. And it's very convenient for bike riders, biking in North Europe in winter. So you don't have that weird feeling on your brakes. So
yeah.
And in the end, we jumped on the mineral oil, but only once we had the right oil for our brakes.
Yeah, interesting. Well, you mentioned that brakes are a closed system, and so you need to make sure that the only thing that's in the system is that oil. There's no air bubbles or things like that. And once those bubbles do form, you need to bleed the system, right? How do bubbles get into a system in the first place?
Well, many ways. I would say many ways. Of course, the first one is that they're not properly bleed. That's the first reason. So
yeah, it's there to begin with.
And the most common. Yeah, and that's the most common one. And when I'm saying that, I'm not just saying that is the customer or the rider. It can be the factory. But please consider that most of the time when you get the new brakes, you're going to shorten the hose.
Right.
So I would say that the case, or put it in a different way, 90% of the time, maybe even more than 90% of the time, when you get a new pair of brakes, you short the hose, you put it on your bike, and you rebleed. So not very often you are riding with a factory bleed. At least it's not the brake that you find on your bike, the bike that you are buying at the shop. So that's the first bleeding. Then it can be something in the system, because the system is not 100% sealed, I would say. And this could be many, many things. For example, could be because the system is damaged. Can be from the factory, or can be because you crashed, you bent something in the system, and then by using that, you get some air in. Or maybe you are using the wrong kind of oil, and the oil would wear the O-ring in a bad way, because it's not the right oil for that brakes, and then you will get air in it. Or maybe, for example, we do this often we face that often with our brakes. You're not using original pads, and you are using pads which are painted in the plate. Mm-hmm. And because they overheat, that painting will melt and will stuck into the pistons and can damage the piston, or causing more friction or more like free space between the piston and the caliper, and you get air in it. So it can be many, many reasons why you get air in your brakes.
Interesting. And it sounds like, too, the hose is a part of that as well. I mean, the hose, I would imagine, needs to be designed to handle those pressures and to not, wear out or introduce holes or gaps or anything, right? Like, how important are the hoses?
The hose is very important. And of course, this is one of the first things that when you damage, you will get air into the brakes, because maybe you scratch the hose somewhere because of a crash or stuff like that. Mm-hmm. And it is very, very important. For example, we have two lines of hose that mainly are available for our OE. And one is Kevlar, which is way, way more expensive. Mm-hmm. This is the reason why we don't put it in our aftermarket brake. And is less compressible. It will expand less than a standard hose. Okay. That means that you have even more bite on the brakes. But this doesn't mean that is necessarily better, because maybe you want a different feeling on your brake and you don't like a very strong bite. So a Kevlar hose will not be ideal for you. Yeah, this is very important. One thing that it's very important to understand, that designing a brake that is good for every riders out there is impossible.
Yeah.
This, I kid you not, it's not possible. You have to do compromises because the brake is probably the components on your bike which is more related to, if you think about that, maybe even more than suspension. If you have a rider that maybe is not really into suspension, maybe it can go away even with a not really nice suspension set. But most of the riders, they are kind of picky on their brakes and the feeling, the position, the lever, the distance of the lever. So the brake is a very sensitive component from this point of view.
Yeah. Well, yeah, it seems like that makes it a real challenge to offer products, that fit everybody's needs. And one of those areas is brake adapters. I mean, most people are going to need an adapter depending on, the size of rotor that they use. Is it just a manufacturing reason for not designing the calipers for a certain size of rotor, or is there something else going on?
Well, we don't really have this approach because our calipers are good for any size of rotor. So you can use, even with the Cura 2-piston, you can use a 203 rotor and a 203 caliper. And we always did like that. So if you're talking about other manufacturers, I'm not the right person to answer to that thing, but I assume as a consumer that you also need it because you have to have a wider range and to categorize better your brakes. So, and you want people to have, like, let's say, a more specific product for cross country, let's say, and a more specific product for downhill. And but this is not our approach. When we first came out with the Cura 2-pistons, I personally had a very hard time trying to explain people the intended use, because the intended use was just stopping bikes, and then you choose the bike, to be honest. And the Cura 2-piston was used at the Cape Epic and then at the downhill World Cup. So what's the intended use? I don't know.
Right.
It's a brake. It will stop your bike. So, it's not our approach. We do brakes. If we do differentiate our range, we do mainly based on weight. For example, you want a lighter brake for your cross-country bike, and you don't really care about weight on your enduro bike. But that's the only difference, not really based on power or design.
Yeah. Well, what are some of the design considerations when it comes to disc rotors? I think most people recognize that larger rotors are typically going to be found on more gravity-oriented bikes. But what are the things that you think about in terms of sizing the rotors?
Well, when you design a rotor, and this is very challenging, designing a rotor. First of all, because when you design a rotor, you're designing pretty much three rotors, three different products, because you have the 160, the 180, and to the 203. And it's not necessarily true. I would say that it's always wrong, or let's say not true, that a good design for the 203 or the perfect design for the 203 is the perfect design for the 160. So, because they are very different rotors. So you have to find a compromise. And often you will see also in our range that they seems to be exactly the same rotor, but they do have differences. Even if the main shape is the same, but maybe like the arms or other little things are a little bit different, because you cannot do exactly the same rotor and making it just bigger or smaller and pretend it's going to be perfect for that size. So that's the first thing. Then again, it's a compromise. For example, the rotor we had before, the actual one, was a super light rotor, and it was very, very thin. Some people loved that because it was very light on the bike, and because the bite was super strong, the way I was designed with the big holes and stuff like that. But it was a little bit noisy, because if the rotor is thin, you have more vibration, and this vibration can resonate with the frame, especially the rear brake, and give you noises. And we had this time where some people was actually liking that noise, because I'm not talking about squeaking brakes. Yeah. It's not kind of noise. It was more something like a zzz, something like that.
Yeah.
and which is typical of motorcycle. I don't know if you have experience with motorcycle. This is typical for motorcycle brakes. And some people that was motorcycle and mountain bike people was loving that brake. But for example, a lot of bikers, especially in Germany, in Europe, which are very picky with noise, I would say also in Canada, they were just like, no, you need to do a rotor which is a less noisy.
A quiet rotor.
A quieter, exactly. So, and then we designed the new one, which of course is thicker. And it is quieter, but you have more modulation with this one. Because it's like a cover. It's like it's the same sides. When you push one side, you're discovering something from the other side. It's like you cannot have everything at the same time. So now our rotor is quieter, but it will take a little bit more time to wear the pads, to bed in the pads a little more, and is less bitey, I would say, than the old one. Most of the riders like it, but some riders say, the old rotor was better. So again, there is no way to make a perfect brake for everyone.
Yeah. Well, is that something that people could do though? I mean, could you swap out rotors? I mean, I know as a manufacturer, as a brand, you would say, no, we've designed this system to work together, this rotor with this caliper. But obviously there's a lot of aftermarket choices. So is that something people could do if they're looking for a different feel, to go with a different rotor from another manufacturer?
Yeah, okay. So from our side, we still have the old rotor if you're looking for a different feeling. But we do not really encourage people to change rotors or pads, because especially pads, but also rotor, because that product is designed to have that performance with those pads and those rotors. So we cannot guarantee the performance. Of course, it can happen that someone out there is better than us in designing rotors. It can be, of course. But we spend a lot of time designing our rotors. So, and every rotors we proved out there and we tested out there, it doesn't perform good as our rotor on our brakes. And trust me, we test a lot of rotors. So this is the reason why we do not encourage people to do that, because the performance will be not the same.
Yeah. That's good to know. And then I also imagine a big part of rotor design is heat management, right? And is that the main thing that drives the using bigger sizes, or is it something else in addition to the heat management?
Well, heat management, that's also a big question, because I think there are a lot of misconception about heat management on the hydraulic brakes in mountain bike. Of course, if you have a thicker rotor and if you design that in a certain way, will manage the heat in a better way. But the first source of overheating, is the way how you brake. And if you brake just too much, but like too much, you can design the rotor as you want. You will have heat issues.
Yeah.
It's not so. It really depends the way how you use the brake. For example, let's say that you are on the Alps or coming down with your car on a very long downhill in the mountain. You know that you have to brake with your engine. You cannot brake all the time with your brakes. And could be also, I don't know, a Tesla, a Porsche, a Ferrari, whatever you want. If you brake all the time in a bad way during the downhill, you're not surprised at the end of the downhill that your brakes are not in a very good condition.
Yeah.
You're not blame Ferrari or Porsche or Tesla because they did a bad brake. So you say, no, I have to learn how to brake with my engine, how to use. It's the same with brakes. So to answer your question, of course, the rotor, if you do a thicker rotor special design, you can manage the overheating in a better way. But as a rider, if you have that kind of issue with your brake, the first thing you have to learn is how to use your brakes.
Yeah, that's a good point. Yeah, that a lot of it is mostly just user error. So is there any meaningful advantage to center lock over 6-bolt rotors? I know you probably offer your rotors in both configurations. Is one better than the other in any way?
Not really. From our testing, we have rotors in both design. It's really a matter of, let's say, compatibility, but not other issues. So they are pretty much the same in design. I would say that in long term, but this is I do not take this as a formula statement. It's more as a right. My experience with center lock is that sometimes depend on the cassette you're using, especially on the hubs you're using, especially the rear brake. Mm-hmm. They can have a long distance a little bit more of play compared to a bolt-in brake rotor. So I do prefer bolt-in because for me is just longer life.
Yeah. And I mean, there are trade-offs just like everything. I mean, center lock, in some ways it could be an easier, quicker system for swapping out rotors. Not that people do that very often, but yeah, there are pros and cons for sure. How does the moto world influence mountain bike brakes? Is that sort of driving some of the innovation, or is mountain bike braking sort of its own category and seeing its own innovations apart from the moto world?
Well, I would say that the moto world does not really affect the mountain bike because the hydraulic brakes hydraulic disc brakes are pretty much the same on mountain bike and motorcycle. Of course, on motorcycle, you're looking for different powers. All the sizing is different. You have different rotors, so you can go heavier. But the main concepts behind the technology are pretty much the same. So I would not say that a motorcycle brake is a completely different technology compared to a mountain bike. So in that sense, they influence each other. What you discover and learn in one of the two fields is you can apply on the other one. In this sense, they will affect and influence each other. But on the other hand, the technology is very similar. Now maybe we're facing a time where at some point we will have some I wouldn't say cross compatibility, but cross influence, because with the new cargo bikes and heavy e-bikes, I can see in the future a mountain bike brake which look, feels, and based also on weight and sizing, it feels a little bit more like a motorcycle brake. I can see this happen in the world. Maybe not for the pure mountain bike scene, but think at very big commuting e-bikes or cargo bikes.
Yeah, that makes sense, where weight isn't as big of a consideration, weight of the brake itself, and then also the bikes are heavier, just like motorcycles. And so, yeah, that makes sense.
Yeah. For instance, if you live right now, I don't know, probably also in US, do you have cargo bikes doing?
We do,
delivery? Yeah, doing deliveries sometimes in some places.
Sure.
Yeah. think of those bikes. If those bikes use just a standard mountain bike brake, which is what they do most of the time, and think at the average day of a delivery guy, their pads is done after one day. So they will change. Literally, they change pads every day or every 2 days. This is not something you do on a motorcycle. So on that kind of technology, you need something different. On that kind of vehicle, you need something different. It needs to be light, has a mountain bike brake, has to be the same size, lever, master cylinder of a mountain bike brake, because in the end, you are riding a bike. But the pads needs to be way bigger as a motorcycle pad, for example. So I see some cross influence coming in that field at some point in the near future.
Yeah. Well, what are some of the biggest or most important innovations that we've seen in hydraulic disc brakes since Formula started making them?
Well, a lot of innovations. There is also a big topic about Formula started. I remember I talk about that with journalists a lot of time, because Formula, we aim to be, we claim actually to be the first company who did full hydraulic disc brake for mountain bike.
Yeah.
That was 1993.
Wow.
Some people say, no, it's not true. It was Shimano first. There was Hope, but that's the story.
Yeah.
Shimano
since the beginning, for sure. I mean,
Shimano did a full hydraulic disc brake for a bicycle, but not for mountain bike.
Okay.
And this is not a small difference, because they had this kind of technology before the 93. But they put it on a standard bike, city bike, and then they remove from the bike, and then they jump back a couple of years later. That means that whatever the reason is, they never release a full hydraulic disc brake for off-road use for mountain bike. Then before 93, there was two companies in US that they had disc brake with hydraulic caliper, but mechanical actuation from the master cylinder, which, for what we said at the beginning of our conversation, is not exactly the same. So Formula was the first company to do a full hydraulic disc brake for mountain bike use in 1993, and Hope came the year after in 1994. I would say we were pretty much at the same time with Hope. We just release it couple of months or like half a year before them. And then they were the first one to do a 4-pots hydraulic disc brake for mountain bike. And then, if you ask me, we did a lot of innovation based on what mass production means, because for example, when we start doing this, that was not such a product as a full hydraulic disc brake for mountain bike. So there was not a hose supplier or rotor supplier. So, and back then Formula was building frame using as hose, the hose you can find in the cockpit of a construction crane, for example.
Wow.
And as rotors, we were having rotors done by a supplier that was knife blade suppliers, because so everything was really at the very beginning. So you had to figure out how to make things work. If you come at Formula, most of the machine we have in production are built in-house, and we still use that. And some of them are, for example, bleeding machines, because if you do mass production, you need to have a bleeding machine. You cannot have the operator doing the bleeding just one. So a lot of things. So we did a lot of stuff based on that. Then the main differences, I would say the big advantage I see, I think highest was was a very innovative company back then, because they were the first one who brought on the market a wider rollback. So the distance in the quiet, let's say, when we're at quiet, how do you call them? No, quiet maybe is not the right word. Do you know what the rollback is in the caliper?
No, I don't.
It's the distance between the pads while you're not moving the master cylinder. So when they are static.
Right, when they're retracted.
Exactly, when they're retracted. That's the rollback. And back then, at the very beginning, the rollback was very low on brakes, very narrow. So you had a lot of centering issues, noisy, rubbing, stuff like that. Hayas was the first company to bring a wider rollback in the mountain bike use, which was important because in mountain bike you have lighter rotors. They can bend. Sometimes they're not 100% straight. And you can perceive the noise easier on a mountain bike. This kind of technology, like wider rollback, is mountain bike specific. On a car, motorcycle, absolutely no problem. You will never hear the noise or the rubbing noise of the brake. You want less rollback because it means that you have more, not more bite, but is a little bit safer. Let's say that the time while between the moment you push the brakes and the master cylinder and the actual brake is smaller if you have less rollback.
Yeah.
So, and of course, with motorcycle and cars, you don't have the problem that your rotor can bend because they are way bigger. So Hayas was the first one too, and I think that was a big improvement in mountain bike hydraulic disc brake.
Yeah, that's interesting. That's something I hadn't thought about. And, even as a home mechanic, it still is frustrating sometimes to, line up the rotor and get it in between the caliper. It seems like those distances are very tight, but yeah, I guess that they used to be even tighter. And so that's
Exactly.
Cool. And also, what in terms of performance, how have the brakes changed since 1993? I imagine, are they more powerful now? I mean, what you're saying earlier is that brakes are plenty powerful for most people, but were they in those early days? Were they as powerful back then?
They are more powerful, but you have to put this in perspective. The mountain bike, full hydraulic disc brake for a mountain bike started in 93. And in 93, we already have the technology to stop a Formula One car. So the thing is that the reason why today are more powerful is not because only today we are able to design that with more power in it. It's because the mountain bike changed. And now the mountain bike are lighter, faster. The average mountain bike is way faster and requires, based on the style and the trails that you ride, it requires more power. So you have to develop a brake. So, yeah, to answer your question, they are more powerful, but not because we could not design with all this power back then, but just because the mountain bike evolved and we had to match this evolution doing more powerful brakes. Of course, what really changed is the ergonomic. The ergonomic has improved a lot in the years. That's 100% for sure. But also the riding style has changed. The ergonomic has changed because at some point of the mountain bike history no one was allowed anymore to brake with two fingers.
Right. And I assume that was the switch from mechanical to hydraulic, but in 1993 with Formula's hydraulic disc brakes, did you need to use two fingers, or was one enough to make them stop?
Let's say that we designed the very first one with a longer lever because we knew that the riders were braking with 2 fingers. So that brake was designed to brake with 2 fingers. You could make it work with 1 fingers, but all the ergonomic was made to make it works with 2 fingers. Yeah. Because we were not going to, we didn't want to change riders' behavior. We were designing a product that matched their riding style and their behavior. And back then, everyone was braking with everyone were braking with 2 fingers.
Yeah. Again, it's the market. The market is kind of dictating what you can do and limits, how much you can change at once.
Yeah.
So, what is the formula philosophy around brake pad components? I think most people are familiar with the metal and resin options, organic. But yeah, what's kind of the brand's philosophy around those pad compounds? Is one better than the other, or is there one that can kind of do all conditions and serve all riders?
Well, they are different. So it really depends on the use you're looking for. The organic pads are a little bit softer. I'm an organic pads guy. I do prefer organic pads, but because I do not do super long descent and I don't use the brake that much, not because because I'm super slow, so I don't need to brake that much.
But you know how to brake too. I mean, you're not the guy that's holding on to the brakes the whole way down.
No, I try not to hold on my brakes all the time, but the kind of riding that I do not really require that sorts of style, that kind of style, because I do not ride super steep or long trails. Mm-hmm. I'm more a trail rider.
Right.
So, and this is why I do prefer organic pads, because they are way faster to bed in. They do not take time to get in the right temperature to deliver the right power. So pretty much the first brake on the tour is a good one. And because I do not ride a lot in the mud or very steep condition, I don't use the brakes that much. They have a long life, I would say. I don't need to change the pad all the time. But if you are super peaky with the power and you want to you ride super steep descent, long descent, you're riding a lot in the mud. Mm-hmm. You probably, and you want in this situation to have a good power all the time, and do not change your pads every month.
Yeah.
The sintered one are a better option, but the low point this is just my point of view as a rider. Of course, a sintered pad, it will take a little bit longer to get at the right temperature. Mm. That was more of an issue back in the days. Back in the days, like a sintered pad, a metal pad, required temperature. It's like, I remember pads back in the day where I'm talking about 10 years ago, is like if you do not do a warm-up process, you don't have brake power at the very beginning.
Yeah.
Now it's completely different, but still it's not like the organic. And of course, because in the end, the metal sintered is harder than the organic, mm-hmm. which is softer, is a little bit noisier. So if this is also important for you, with the sintered, you could have a little bit more noise. This is the reason why aftermarket, all brakes, all brands are sold with organic, because no one wants to have a noisy brake on a brand new noisy brake.
Right. Interesting. Well, one of the things that you mentioned was about braking technique and learning how to let off the brakes. You know, a lot of issues, or one of the issues that people run into could be due to user error, that they're just holding their brakes too much and that's what's heating them up. So are there other misconceptions or things people don't know about proper braking technique? And are there ways that as riders we can get better performance out of our brakes?
Yeah, there is one. There is one, especially one that sometimes drives me crazy. It is the on-off myth. This brake is too on-off.
Uh-huh.
And again, make you an example. The cars. Cars are always very good for example, talking about brakes.
Mm-hmm.
I have a Fiat Panda, and the Fiat Panda has the brakes that a Fiat Panda is supposed to have. I mean, they are not super powerful brake. And I do brake on my Panda the way you are supposed to brake on a Panda. If I jump on a Ferrari with Brembo brakes and I do brake the same way I do brake on my Panda,
Mm-hmm.
I will not move at all.
Yeah.
I will not move, literally. What does that mean? That the Ferrari or Brembo engineers build I don't know, $3 million car with a brake that is too on-off?
Right. No.
No. That means that those are performance brakes, and you have to learn how to use it because they are built on a performance bike. Of course, if you have, let's say, a not very good brakes, and you are used to drag your brakes constantly, and you are still moving and going down the hill because your brakes are not that powerful, and you do the same thing on a good brake, you will not move. You will stay there.
Or at least you'll lock your wheel up. I mean, that seems to be the problem people have. And once that happens, yeah, you don't have control.
Exactly, because if you have a bad brakes and you brakes the same way on a good brakes will stop your wheel. And if you brake all the time, you will not move, and you go down the hill pretty much with your forearms destroyed, blaming the brakes because they are too on-off. But if you think about that, if you learn how to brake, a good, powerful brake will save your forearms because you can brake less, you can brake later, and you can brake softer. But you have to learn how to use it.
Yeah.
So on-off is a big misconception. Please, if you see readers or people listening to us that are going to the bike shop and then are testing the brakes on the parking lot, just pedaling a little bit and then boom, just to see, this is not a good test.
Yeah. Well, what about locking up the rear wheel? I always think, again, getting back to thinking about car brakes, you know, most, if not all, modern cars have anti-lock brakes where, you know, over time people learned that sort of feathering the brakes, you know, like especially in an emergency situation, like pumping the brake and letting off, pumping it, helped. And so automatic braking systems now do that for you, right? It like, I don't know what the word is, but it, you know, goes on and off for you. Yeah. Is there a similar analog for mountain biking? I know people have tried it. There are systems out there that claim to offer a similar performance, but is there a way to do that with your hands? Like, would that be helpful?
Yeah, I mean, we've talked so many times about ABS on mountain bike brakes or bicycle brakes. Mm-hmm. I don't see that happening because can you imagine a bike where you do not have control of your brakes?
Right.
It's easier on a car. You can have weight. You have pretty much all cars have electronic right now. You can put a very big piece of chunk electronic things in your car, which is heavy. And it's different. The mountain bike is different. It's a different sport. It's a different vehicle. It's also a two-wheels vehicle. It's not exactly the same. So, yeah, I don't see ABS being maybe on cargo bikes, but performance riding, mountain bike, enduro, trail. I would not be relaxed with that kind of system.
Yeah.
I want control of my brakes.
Right. Yeah. It's hard to trust it. But yeah, we are seeing electronics being added to more and more parts of the bike. We're seeing it even in suspension, where it controls your suspension. And yeah, obviously that hasn't taken off in a big way with riders, at least, because it does take away that control, and it's hard to sort of trust that.
Yeah, that's true. But if you think about electric cars, some of them, they have the electromagnetic brakes, but they have the mechanical too, just in case those brakes fails. So just an emergency case. So it is, I don't know, maybe I'm wrong, but I don't see this happen on mountain bike, at least not in the near future. Talking about blocking the wheels, of course, we're talking about the rear wheels, because the front wheels would be dangerous.
Right. You definitely don't want to lock that one.
Yeah, I think if you design the brake in a good way, because you have modulation. Sometimes the modulation is very important on a brake, because it's not necessary the way how many times, let's say, you pump on the brake, but it can be also the point where you are with your lever. So you're applying less or more power. So if you have a good modulation and you learn how to use that modulation, you can easily overcome the issue of blocking your rear wheel. Of course, sometimes we faced many times as a mountain biker that situation where at some point everything is out of control. You are in a steep trail, and your instinct is to pull the rear, and this doesn't really make everything easier because you just start sliding down the hill. But I don't think you can really do anything about that besides learning how to ride steep trails better. So.
Yeah, that's good advice. So finally, I want to ask you, what are some things that could possibly be improved about modern disc brakes for mountain bikes?
That's a good question. Again, the next step that I see is on having the right brakes for a new generation of bikes or vehicles. So for the standard mountain bike, the bike that we see right now, we are in a good spot with brakes. I don't think the brakes that you have out there are not enough to manage what these bikes can do. Of course, if in 10 years' time we face the same revolution we faced in the last 10 years with wheel sides and downhill, and we have the riders that will ride the downhill courses twice as fast as they were doing 5 years ago, may we have to redesign the brake. As we were discussing before, the brakes will evolve with the bike. If the bike gets faster and more extreme in some sense, maybe at some point we have to do it a more powerful brake. But for now, we're plenty of power. I don't see that happen. Different for new vehicles, because e-mobility is at the very beginning and has already brought to the market new vehicles like the cargo bikes, for example. So we don't know what other kind of vehicles we will have in the future for e-mobility. So maybe at some point we will have to develop new product for those specific vehicles.
Yeah, interesting. Well, Vittorio, thanks so much for taking the time to talk to us about brakes. I know I learned a lot, and I'm sure our listeners have as well. So thank you.
Thank you very much. Thanks for having me. It was really a pleasure.
And you can learn more about some of the brakes that we talked about specifically here at rideformula.com. That's all we've got this week. We'll talk to you again next week.